Okay, this question says a spring requires 10 joules to stretch 5 centimeters. So you have an original spring, you want to stretch it an additional 5 centimeters so that this right here is 5 centimeters. And you say that that takes 10 joules of work. Okay, we want to know how much energy is required to stretch it an additional 12 centimeters. Okay, so what we want to do is we want to say, okay, I want to stretch it so that it's actually 12 centimeters further than it was in the second situation. So what you should realize is that the displacement from the original position is not 5 centimeters, it's not 12 centimeters, it's actually 17 centimeters. Okay? By now you should know that centimeters are not something that we deal with. But really that's the only piece of information that we have. So we're going to have to use this first situation that it gives us in order to figure out what the K value is. And so this is actually a two-step question. Ultimately, I want to know what the energy is. But in order to do that, first I'm going to have to solve for what the K value is. So what I'm going to say is I'm going to use the equation PE equals 1/2 kx squared. Now, I am going to use it twice for two different situations. So let's look at the first situation. The first situation, I have an energy, I have a displacement, (5 centimeters converted, and it allows me to solve for the K value. Now, since it's the same spring, once you solve for the K value is going to be the same in both situations. So, you can say PE equals 1/2 kx squared, so I forgot the K value, and you could solve for K. What I'm going to do is I'm going to do it algebraically. I'm going to say, well, I'm going to multiply both sides by 2 divided by x squared, and when I do that I get 2 PE over x squared equals K. Now remember, the K is going to be the same for both situations. So, if I were to somehow just say equals 2 PE over x squared for the second situation, I've got a ratio. I don't even have to solve for K. So what I can do is I can say, okay, well, originally I had 10 joules of potential when I stretched it 0.05 centimeters, or excuse me, 0.05 meters, which is 5 centimeters. Now, in the second situation, I want to know how much energy I have whenever I stretch it a total of 17 centimeters. Now, a lot of people will make the mistake here and they'll say, well, they'll plug in 12 there. But remember, this is stretching in an additional 12 centimeters. So it's stretched a total of 17 centimeters, which is 0.17. Well, at this point, you basically have one unknown variable. You can just cross multiply and you can solve. So what I'm going to do is I'm going to cross multiply, and I get 0.05 squared times 2, and so that is 0.005 PE equals 2 times 10 times 0.17 squared, 0.578. So now, divide both sides by 0.005, and what you get is, you get a potential energy of 115.6 joules. And so that just kind of puts it in perspective. Really, you're just about doubling, tripling the length, but your kinetic or your potential energy goes up quite dramatically. So you got to be aware of those sorts of things. So now, one other thing real quick, we went ahead and eliminated K. If you're not comfortable with what we did, you could always use the first situation to solve for K and then plug it in again a second time. We just showed you, we kind of skipped that step, but it's something that you could do if you're more comfortable doing that.